We now move to do some limit problem. In calculus we have this concept of limit, where we see whether that value, limit of that value, exists or not, and if it exists, then we can find the value of that limiting values. That means, suppose if we take a question here, say your question says, does limit, this limit we can express it as lim, and we write below x tends to 4, limit x tends to 4, square root of 4 minus x. So this is like I am finding the limit of this value, square root of 4 minus x, and I have to check, does this limit exist or not. So what does this mean? This means when x is approaching towards 4, when this value is approaching towards 4, whether that this value exists or not. We can find that this value exists when this x tends to 4. I mean, when x is approaching 4 from both right hand side and from the left hand side, if both exist, then we can say this whole limit of this value exists. What I mean is, let me show, that will be good for you. Okay, so the first step I do is I write this this inside, I mean limit of something I'm finding out. So this is a function of x, right? So I say let fx equals square root of 4 minus x. So you see that this I'm finding the limit of a function. So that function is fx equals root over of 4 minus x. And then I say, when x tends to 4, when x tends to 4, x tends to 4 minus, I write 4 minus means that is x is approaching 4 from the left of the point x equal to 4. X is approaching 4 from the left of the point, x equals to 4. Then we can have the following table. Where we will show if the value of x is something excuse me, what is the value of fx. So let us make a table here. The kind of table we do for finding t table for x, y, similar thing. I take the values of x in the upper column, and I mean upper row, and below I take the values of fx. So if x equals to 3.99, what is the value of fx? You see here, if x equals to 3.99, so 4 minus 3.99 will be what? Square root of 0.1, right? Let me show here, 4.00, and you are subtracting 3.99 from here. So this is 10 minus 9 is 1. this one comes here, so this is 0. 0 minus 0 is 0. Point, this one comes down here, 0. So this is 0.01. And square root of that value, square root of 0.01 is what? I take square root of 0.01 equals, this is, if I take 1 by 100, because decimal point is after 2 digits from the left side, so this is 1 by 100, and I take out this 100 from here, that means 10 into, 1 by 10 is the value, right? 1 by 10 means, in decimal I can write 0.1. So when x equals to 3.99, fx equals to 0.1. Next, if I take x equals to 3.9999, we will find, by putting the values similar way, fx is coming as 0.01. Similarly, if I move further, if x equals to 3.999999, see, all these values are approaching towards 4 from the left hand side, right? 3.99, 3.999, all these values are approaching towards 4 from the left hand side. So that is x tends to 4 minus, and here fx will come as 0.001. And this way we can move on, so etc. From this table, it is clear that when x approaches 4 from the left of the point x equals to 4, fx gradually approaches, you see, from point 1, then 0.01, then 0.001, x approaches 0. So we can write as x tends to 4 minus, fx tends to 0. That is, the numerical difference between the value of the fx and 0 can be made as small as we like, and we can write it as this way: fx tends to 0 when x tends to 4 minus. So that is limit of fx, I write here x tends to 4 minus equals to 0. That means as x tends to 4 minus, this fx is approaching toward 0. That means limit of fx is equal to 0, or f of 4 minus 0 equals to 0. Now this part from approaching from the left hand side, we have seen how it comes. Now we have to see what happens when we move from the right hand side, that is x approaching 4 from the right hand side. So when x approaches 4 plus, when x approaches 4 from the right of the point, x equals to 4, that is x tends to 4 plus, what happens then? if we put that similar xy table, x and fx table, x approaching 4 from the right hand side, that means I have values like 4.1, then 4.01, then 4.001. This way it can continue. Then for each of these values of x, we see that fx is imaginary. That means if x equals to 4.1, fx is what? Square root of 4 minus 4.1, and you get a square root of minus, you get this is equals to square root of minus of 0.1. So this is an imaginary value. So I am getting for x tends to 4 plus, fx is imaginary. That means I cannot find the values like I did in the earlier case. Hence we can say this function does not exist. Hence fx does not exist when x tends to 4 plus. When x tends to 4 plus, that means x is approaching 4 from the right hand side. In the other words, we can say the right hand limit of fx does not exist. That is limit of fx, I take x tends to 4 plus, does not exist. And I have said both the limit from the right hand side and the left hand side has to exist for the function to be, limit of that function to be exist. So we can conclude that limit x tends to 4 fx equals limit x tends to 4, my function was square root of 4 minus x, does not exist. And here you can also check that if you write f of 4, that will be square root of 4 minus 4 equals to 0. Thus, if fx equals to square root of 4 minus x, then f4 exists, but limit of fx does not exist. You can find the value of f4, but you don't have the existence of this function.